Let's wait for a couple more minutes that the people join in. Yes, Ashish, Rahul. So first of all, you should install Wireshark. The steps are given in that worksheet. Okay, means special instruction sheet. May it is given. Once you do that, you have to connect, link that Wireshark tool. Once you link it, type Wireshark, it will automatically start. Then there is a option for capture packet and stop the capturing. So when you start capturing, there should be some network traffic being generated there. For example, say you maybe started one website, opening an website, so that like to and fro data traffic will flow. So basis that it will try to capture the packets. So those packets, once you save that file in the form of pcap, we call it as a pcap file. So this is called as a traffic which is being captured. From that file, now you need to analyze with the help of Wireshark tool what type of traffic has been flown. Is it a protocol based on TCP, HTTP, HTTPS, SNMP, DNS? All these things, details will be there in those things. So there is a search bar in the so filter करने के लिए there is a search bar. Put your command there, just like how you put a prompt or a command. Same way it will going to help you by filtering those things. That's exactly what Wireshark do. I hope I have answered your query, Ashish. follow this complete instruction so that you will be able to meet this thing. App work. So first of all, that is the OSHA opening. It put this command called sudo dnf install. Password it will ask, it's a cloud. Once you install the Wireshark tool, now sudo like user mode -ag Wireshark for user to connect. Either you use these commands or you may use one more is there called Wireshark installation page also. That also you can use. See, with along with the screenshot they have given. It should help you.
Can you ping this command in the chat?
I'm doing it. Here you go. Okay. I think this sheet already I've shared, no, last week. If you want, I can share it once again.
Yes, sir. Yes, sir.
I'm doing it. Any other queries, guys, from the previous classes or something? So today is the 8th session, contact session 8. So generally we used to have this 8th reserved for the revision. But this time since AI is a new catch, so the management or the bits management has decided to offer a AI related thing. Okay, that's what exactly we are here for the today. Then coming to this, I don't think so. You can expect the questions from this particular chapter. So that's why you can use it for more troubleshooting kind of stuff, etc., rather than the thing. So in the last class, we were looking at the SNMP version 3, which is much more improved version of the SNMP version 1 and 2. Whatever the limitations were there in 1 and 2 are being taken care in the version 3. We looked at the features, SNMP engine, and then the SNMP version 3 applications and primitives, SNMP architecture, user security model, etc. Okay. And one more important thing I wanted to bring it to you. Please use your what is that? Chat GPT thoroughly, or maybe the Microsoft Copilot, whatever the AI model you have. So use it so that it will help you, even including Wireshark also, it will help you to give the steps. Okay. So, but make sure that you practice it. Yes, nobody on the earth remember each and everything. I am also human being, you are also human being. Only difference is I may be double the age of yours, and with that doubling that one type of age, I have acquired enough experience. The more you practice, the better you are. Right. I think I need not to tell you that is already you are working on the ground for the job related thing. The same thing is true also. Whereas in my life, I've been like, as a teacher, I used to teach a lot of difficult subjects like compiler design, computer architecture, advanced computer architecture, system programming, these type of things while I was a faculty. After I migrated to Oman and Libya, there I understood, okay, we have to teach practicals also. Then afterwards, I came back to India, started as a corporate trainer. So then I realized that, oh, theory will not work. So we have to show each and everything, demonstrate to the user so that they will learn practicing it. And when you are practicing it, you will get a lot of errors. As a teacher, my advantage is that like students are asking the questions. or help me, sir, I got stuck here. So as a trainer or a teacher, you have to help them, means you should know the debugging skills. So that is where I thank my student circle for making me strong in terms of debugging any of the complex situations. So as a rather than faculty, as a trainer, I struggled a lot to learn these hands-on, because you have to show that tomorrow in the demo, right? In the class. If that is the case, you should be sure that okay, it is working. And you have to lot of new things you will be exploring. So those times, this Stack Overflow errors, then Googling, that this was helping. But today, thanks to the technology, there is a ready-made person sitting there instead of Google. So ChatGPT is there. Earlier days, I used to tell in my classroom, you should learn the skill called how to Google a Google. But today, you should learn the skill how to prompt the AI or GPT. That's what exactly you need to know today. So please ask questions. It will help you do the. Trust me, I have adopted in my company also, as well as here also, a lot of things. Almost daily, I will be keep using the Copilot. But after you get the result, whatever you get, make sure that it is in line with your expectations. That we cannot simply blindly accept the GPT. Okay. With that, so this is the very well developed to fulfill all the management related things. So security, which is having the much more improved in terms of authentication and privacy, administrations, better authorization and access control. So then additional features like data sets, then fine-tuned DDL data definition language. So threats, whatever the threats were there, so they're all being supported in the text. So SNMP entity and applications and engine are the two entities within the SNMP architecture. So applications usually have a command generator, command responder, notification originator, notification receiver, proxy forwarder, and others. So SNMP engine will go to contain dispatcher, message processing subsystem, security subsystem, and access control subsystem, so that it will be fulfilling the entire things. So that is why whenever there is a SNMP software which is sitting on the management station or on the agent or manager device, so this will be part of the things. So with this, the advantage is that SNMP entity is determined by the modules which are implemented in the entity. So security subsystem and a set of authorizations are going to really helpful and make this as a best version of the protocol. So command generator, notification receiver, notification originator. So this is the processing system, message processing subsystem, security subsystem, dispatcher, message dispatcher. So transport mapping. So one is the message, another one is the PDU, actual protocol data unit. So both will be having a different dispatchers to dispatch the. So dispatcher is going to be accept the PDUs from applications, handle the multiple versions of the SNMP, interfaces with the application module, network, and message processing subsystem. So the three components of the three functions includes transport mapper, routes the messages, and PDU dispatching will be done by the dispatcher. So message processing subsystem will accept the outgoing PDU from the dispatcher, attach an appropriate header, and return the message to the dispatcher. So on the things, it accepts incoming messages on the outside, like opposite side. One is outgoing, one is incoming, right? Process each message headers and return the enclosed PDU to the dispatcher. Basically, it contains one or more message processing model, each of which will have a support particular SNMP version. Security subsystem is to perform the authentication and encryption of the things for both PDU outgoing as well as the incoming messages. Okay. This is the architecture. SNMP engine will be there. Principal is a person or a group of application requesting the services. Security name, which is in the form of readable, human readable format. Then context engine ID, which is the entity of the unique context, context name. So that will help you to join the things. So SNMP entity will have this entire thing, entity 1, 2, 3, like that. So abstract service interface is a conceptual interface between the modules, which can define a set of primitives and the primitives associated with the receiving entities, dispatcher entities, both the incoming and outgoing parameters and status information or the result will be there as a part of it. So one of the PDU that generates by the dispatcher is a send PDU, then process PDU, return response PDU, prepare outgoing message, prepare response message, generate the request message, process incoming message, generate the response message. These are the messages and the PDUs that dispatcher work towards it. The applications which are going to be in this built based on the command generator, command responder, notification originator, notification receiver, proxy forwarder, etc. are the command generator application is used to generate a get request, get next request, get bulk, and set request messages. This is how the command generator will going to do. Send PDU. Dispatcher will prepare the outgoing message, and message processing subsystem will going to generate the requesting message. Security model will going to check the security authentication, etc. And then it will be sent back to the message processing. Message processing system will send back to the dispatcher. Dispatcher will finally send the PDU and then it will get to the network. Through the network, it will go to the other side. So then dispatcher will receive it. Then it sends it to the message processing subsystem where the headers are removed and then sent to the security for the proper validation of it. And now security will send back to the message processing. Message processing will hand over to the dispatcher. Dispatcher to the command generator. The same thing is command responder. So these are the different scenarios where send PDU, then preparing the outgoing message, generating the things, send and receive application, then prepare the data elements. Message subsystem will process the incoming message, then process the PDU. So then access control subsystem return to the dispatcher. Dispatcher again sends it to the message. Message will attach the security to the message subsystem, and then to the dispatcher to the other requester, whoever has been requested. Now the dispatcher receives the incoming and sends to the message for the removing the headers and things, and also check with the security subsystem and then send it to the application. These are the message formats what we have. So global header data will have the header versions will be there very clearly. That's the thing. So then we have a security parameters like authoritative ID, authoritative engine type, something like security related information will be there, and plain or encrypted text will be the scoped PDU, which contains the context ID, context name, data, etc. This is the message format. So various version, message IDs, etc. will be part of. The goal of the security model includes data integrity, authentication, message redirection, data encryption and decryption are the goals of the authentication mode is the data integrity and data origination authentication. Privacy module will going to help you to encrypt the PDU or decrypt the PDU. Then timeline modules will going to help you to redirect or delay in the replay, etc. will be taken care here. So both the authoritative engine and the non-authoritative engines are going to be like, unique for SNMP engine ID, and they synchronizes the clock accordingly so that they can match the things. There is a user-based security model, which is USM primitive across the abstract services interfaces, where authentication service primitives authenticate the outgoing message, authenticate the incoming message, encrypted data are outgoing and incoming. In case of USM, this message processing model and security subsystem will do a lot of privacy authentication and service outgoing messages in this format. Same thing encryption, then sending it back to the. So this is what we have studied in the last class. If you have any questions, I'm happy to take. If not, we can start our today's discussion. Any questions so far? Okay, all right. We'll start with this today's lecture. So that is on the artificial intelligence techniques for network management. So how can we utilize the AI in this network management? So this is what we are going to discuss today, and we try to keep it as simple as possible. So what we are going to cover is, first of all, let us understand the non-AI based model, then the AI based models, how this ML is helping in the networking. So in the machine learning, we have that supervised, unsupervised, and reinforcement learning are there. So that we will touch upon. The role of AI in FCAPS, because one of the important thing of the network management is that FCAPS, so that is fault management, configuration management, access management, then the performance management, and lastly the security management. So that aspects how AI will help. And some sample GPT prompts which will help you to interact. These are the things that we kept it. So as you all know that the traditional network management system fails because the manual configurations, which are going to be based on the command line interface. Then all these commands are based on the rule-based monitors. Human-driven troubleshooting. So human intervention is required for troubleshooting. Reactive troubleshooting. So again, if you do something, it may lead to something else. It reacts to the whatever fixes that you are trying to do. So static rules are the threshold. Alerts can be set or reset. Then growing network complexity. So as and when the network is keep on growing, This leads to the complex scenario. So non-AI based tools includes SNMP polling, syslogs, NetFlow reports, NMS dashboards. These are the some of the non-AI based tools which are using in the traditional model. There are, of course, limitations are there with respect to that. So the limitations include together the static thresholds, high false positives are possible. While we are doing a manual troubleshooting, it becomes very slow in terms of MTTR, mean time to repair. Rule-based systems cannot scale these things, either scale up or scale down cannot be done. Reactive alerts includes no prediction, and the traditional monitoring fails because what is unmuted? I don't know who is that. So in traditional monitoring, majorly fails because of the one is bursty nature of the traffic pattern. We cannot expect sometimes no traffic, sometimes moderate traffic, all of a sudden huge traffic. So this data, a traffic which comes also encrypted. So again, inspection is going to be limited to that because what type of encryption, whether we can see or not, is difficult to gauge. Then we have unknown attack signatures. So we don't know from which end these attacks are coming. So that is, will not be able to trace them. So it's going to be a kind of then unknown attack signatures, then multi-cloud traffic visibility. So more than one cloud is there. So traffic will be more. Real-time decision requirements. So dynamic should be in dynamic nature. So static things will not work there. Some of the examples include data centers with millions of flow per minute. So traffic will be very huge. SD-WAN, so wide area network with a dynamic path selection. So there it will again fail. 5G slicing with the quality of service constraints. So that is also possible. Cloud native, it's an approach. So where that why AI based solution is important. So the limitations to overcome this is going to be because whatever the networking thing that you are having is not a cloud based thing. Means cloud native is an approach for building, deploying, and managing the applications which are designed specifically for the cloud computing environments where maximizing the advantages like agility, scalability, and resilience. See, those days of maintaining their own servers has gone now. It's all like, cloud. All companies now try to put the data on the cloud only and try to so make any applications, that application should be cloud native. So if we make the AI based solutions, it will be highly dynamic in nature. So all the static things can be given away. Network function virtualization. So it introduces the virtualized environment because of the NFV nature. So AI solutions are based on the software or the algorithms defined. So massive in scale, you can scale up or down both in terms of IoT applications, 5G or edge related. So high AI is much speeder than the human intervention. So that's really faster. So of course, there is going to be a complex scenarios also can be very well understood by the AI and analyze and give you the. There is a need for proactive management. So that is also provided by the AI. Now let us look at the ML in networking. There are three types of learnings are there. One is supervised learning, unsupervised learning, and reinforcement learning. What is supervised? I think I don't know whether you guys have studied any machine learning subjects or AI related subjects. Guys, I need a discussion. I have given you the mic permission. You can unmute and have you studied any data science related, ML related, AI related subjects? Anil Kumar, you are telling that sir, some filters are not providing any data in Wireshark. It's not some filters, yeah. In your PCAP file, there is no related traffic will not be there. For example, say you're telling DNS, DNS may not be there in the that particular data traffic that you have captured. So that's why my suggestion would be while you start the capturing the packets, no, you open multiple connections so that varieties of things, one banking domain, one this thing, that thing, etc. You log in so that huge traffic will be generated. Then you stop in the Wireshark and take that PCAP file and then process it further things so that it will show HTTPS, HTTP, all those things will be there. Anil, did you study any AI related subjects? You're telling not yet, then you're all new to the AI world. Okay. So this supervised learning, see, AI is what is a model basically. It can start acting like a human, how human think the same way that also can do. If that has to be done, then there is a enough training should be given to that, right? If I want to teach a TNM network means network management means I should be good at networking. I know some of the protocols. So past I have developed taught several subjects related to the network only. Basic starts with the communication things, then computer networks, then the TCP/IP, network programming using TCP/IP, right? So like that, I have taught multiple subjects. I have studied distributed operating system, distributed computing, I know. So all these things has helped me to deliver this particular thing, right? So now whenever a particular thing comes, we can correlate each of them. The same thing even AI will also do. If that is the case, you should have a particular varieties. So you cannot apply all supervised learning only to the problem or unsupervised or reinforced. So based on the nature of the problem, you can choose the models. These are the three models, that is ML models which are there, supervised, unsupervised, reinforcement learning. So what is this supervised learning is? It's a technique that where we train the model using a data set, providing input and output pairs to teach the algorithm to map the relationship and predict the outcomes. This is what is going to be. So here you have the label data. This is the model, machine model or machine, whichever is going to be there. Then labels. So this entire thing will be input to the ML model. So as along with the test data, based on the test data, it will going to predict, okay, this is the possible outcome. Well, there is an application like intrusion detection, which is again is the security aspect, normal versus attack, fault classification, SLA violation. So these are all some of the things that can be used by the supervised learnings. These applications can be managed with the, what happens is raw input you are giving. There is a supervisor training data set and desired output. Algorithm is there. So that algorithm accordingly it will process and then refine the output, which is going to be all red separate, green separate, and pink, sorry, not pink, violet separate. So what is labeled data then? The data set that has been triggered or tagged with the correct answers called as a label. So a machine learning model can learn the relationship between the input and output. So input features like are the label targets, email, text, spam, not spam. How do you categorize? Yes, there are spam mails and emails, the non-spam mails, right? Network traffic flows in a normal or attacked environment. CPU usage history. Suppose say the CPU usage is 95% now. Because of this, it might increase to 98%. So like that, you can able to predict future workload. Now, I'll give another example. Let us say your semester grade point averages every semester you are scoring around 7.5 SGPA. Now, what could be your CGPA? You can predict. Now, you can calculate. There is a formula, right, to calculate that. The same way, ChatGPT or the AI model will also do that based on the image of the device. So either the router or switches ka images also it can handle. The model sees the input data and it compares the prediction to be correct label. It adjusts itself to reduce the errors. For example, say network management duration is 2 seconds. Packets, 10 packets will come. 1200 bytes of data totally. Then normal label. So 15 seconds, 50,000 packets, 8,000, 8 lakh, sorry, not even 8 lakh, 80 lakh bytes or 8 million, you can say 8 million bytes. It's a DDoS, means distributed denial of service. Is going to be an attack. So 1 second, 5 packets, 600 bytes of data, that is a normal scenario. So now features includes duration, packet, bytes, label includes a normal or a distributed denial of attack. So likewise, you should have a data set. So now basis this, the label data in network management help you to supervise the entire network. For example, say these are the input features you give it, network traffic data. Then you also provide the correct labels. Training model, it will going to vary with respect to the algorithms. So there is a denial, distributed denial of service attack. Then label, which is going to be target. So intention is to predict like this. So what are the algorithms we use? Random forest, logistic regression, then XGBoot are the few supervised learning. Labels can come from human experts, that is manual annotation, historical logs, security reports, then monitoring the tools, known attacks of the data sets, which is going to be the. In case of unsupervised learning, a type of machine learning that analyzes the unlabeled data sets, to discover the hidden pattern structures or the relationship without the human guidance. So there, the label data set and sample pattern was required. Now here, no need of it. So when we say human intervention not required, then this becomes a easy model for the network. So some of the applications includes anomaly detection or traffic clustering behavioral model. So how does the traffic behaves or how does the outcome of the model behaves that can be measured with the. So let us say input data, we have a set of animals. So interpretation, algorithm and processing. So based on the unknown data, unknown output, and there is no training data set, right? So now model treat and generate it as a separate elephant separate, camel separate, and then the cow separate. Output will be. Or if you want, you can also say that it is two elephants, two camels, two cow. Like that also they can take. So unsupervised learning is a different from the supervised learning. There is no normal or attack labels, no predefined categories. Thus, the model finds structured automatically. In the real world networks, most traffic is unlabeled. New attacks don't have signatures. Traffic patterns continuously change. Thus, manual labeling is expensive and slow. So that's why we can go for unsupervised learning, which helps to detect the unknown threats, abnormal traffic behavior, emerging performance issues, and then the configuration anomalies can be easily handled. Example, there are no labels indicating which flow are attacks. So, but we have the source input and destination port. So step one is to learn the normal patterns. Model will analyze the traffic behavior. So most flows will be short duration, low packet count, normal byte size. It clusters similar behavior together. Then step two is to detect the outlier. The flow is around 20 seconds, 50,000 packets, which is as good as 9 million bytes. But this cannot be fit into the normal cluster. The model flags it as an anomaly. So same picture if you take, so different packet size, duration of traffic, basically. And cluster or anomaly detection, so it will go to detect it as an anomaly detect. So the process in the network flow is to collect the net flow or IP fixed data, extract the numerical features, normalize the features, apply the clustering or anomaly detection model. There's a flag deviation, triggers or alert or automations can be taken as a. So thus in the real world, we could able to predict the network behavioral analytics, insider threat detection, zero-day attack detection. Example, Cisco uses the behavioral based analytics in the enterprise monitoring, and Juniper network integrates with the AI driven anomaly detections in its networking platform. You know, you heard about Cisco and Juniper, right? Unsupervised learning, the challenges is high false positives, difficult to evaluate performance, concept drift, that is a network behavioral changes, requires feature engineering. Algorithms includes K means clustering, DB scan, isolation forest, then auto encoders, PCA algorithms are the algorithm that could be used. Where you can use it, group of similar traffic flows, then K means. Detect abnormal clusters, so DB scan can be used. Anomaly detection means isolation forest. Autoencoders so used for the detecting the traffic violations. So PCA for dimensionality. So supervised, the difference between supervised and unsupervised is supervised requires a label data. There is no label data required in unsupervised. Detects known threats, detects the even unknown threats also in unsupervised. Needs to train the data set, learns directly from the traffic, dynamic in nature. Okay. Easier to evaluate, harder to measure the accuracy in terms of unsupervised. And we have this reinforcement learning, which is again another type of machine learning paradigm where an autonomous agent will going to learns to make an optimal sequential decisions by interacting with an environment to maximize the cumulative rewards. Here we have the agent state, some model or action will be there. So that based on the environment, you're going to provide the required output. So input raw data, agent, environment, so output will be produced by the RL in network management automates the complex tasks like routing, traffic engineering, and resource allocation by enabling the AI agents. So that will learn optimal policies through interaction, trial and error basis. It will try to produce the output. So some of the modern networks are dynamic in nature, complex, real-time, and non-linear. So static rules will not be possible because it struggles with the traffic constantly changing, congestion patterns which are unpredictable, multi-objective optimization which is very difficult. Now reinforced learning adapts the things continuously. So reinforcement learning is adaptive network optimization. So there is an agent. Okay. Route traffic adjust bandwidth or update the quality of service. There is a state action reward. So state could be traffic load, latency, packet loss, etc. Based on the environment, what type of network it is it a WAN, MAN, LAN, blah, blah, blah. So anomalies are going to be detected out of this. Example in dynamic routing optimization problem, a network has a multiple paths between the two data centers. Path A, low latency but congested. Path B, higher latency but stable. Path C, variable performance. Now traditional routing like static metrics and manual tuning has to be done. But this will not support our dynamic, right? So for that, we should go for a dynamic routing optimizations where agent observes the current latency, packet loss, bandwidth utilization. Then agent selects actions, route traffic A, path A, B, or C. Network responds to it. Agent receives the rewards plus 10 if the latency decreases, -5 if the congestion increases. So you have agent updates the policies over time. It learns more optimal, then routing decisions can be possible with the help of. Thus, the agent based is called as a reinforcement learning. So RL can also help in congestion control, predict the congestions built up, adjustable queue sizes, dynamically allocate the bandwidth, modify the transmission rate. These are used in the data centers, 5G slicing, SD-WAN, optimal. What are the applications of RL? So traffic engineering in data centers, which are used by the hyperscalers like Microsoft, Google, and AWS, etc. 5G network slicing, which are going to be in dynamic resource allocation, which is very important. SD-WAN path optimization. So smart path selection based on the real-time performance. So that is also possible with the help of reinforcement in the networking. Of course, everything is not easy. There are challenges also. So training instability. Sometimes enough patterns are not trained properly. Explorations versus exploitation trade-off requires simulation environment, risky to test in the live networks. Reward design in which is a very complex scenario. So summary includes supervised, unsupervised, and reinforcement learning. So learning from best for. What is that? Learning from label data. Unsupervised, it's going to learn on its own for the patterns. Reward feedback is there. So based on that, it will go to learn from the. So now supervised is best for attack detection. Unsupervised is best for the anomaly detection. Reinforcement is best for the best suited for the routing and optimization. Then, what is the role of AI in FCAPS? As we already know that F stands for fault management, C stands for the configuration management, A is accounting management, then P is performance management, S is security management. So as per this, we can still use the AI to help here. So the traditional approach, SNMP traps are used, which are static threshold alerts. Manually, they are troubleshooted. Reactive problem resolution. So based on this, we can go for AI. Now AI will help in predicting the hardware failures before they occur. And it also helps in detecting the anomalies using the unsupervised learning. Perform the automated root cause analysis. RCA can be done and find out the errors. So future it can predict easily. Reduce the mean time to repair. MTTR time duration will be reduced. Correlate multiple alarms into one incident. Example includes predict the link degradation, then identify the failing routers, detect the intermittent packet drop. So these are really helpful, especially in terms of bigger networks and like its human intervention is highly impossible. That can be made easy with the. Second one is configuration management. So traditional approach includes manually configure with the help of command line interface by providing the commands. So now template based provisioning and human policy validations are the traditional approach. But AI will tell you intelligent configuration validation, drift detection. That is the detect the misconfigurations, very important. Auto remediation using the policy learning, predict configuration impact before deployment, and then the intent-based network. Example, if configuration change increases the latency, AI will revert automatically. Account management is going to be something like traditional approach includes flow counting, how many are outgoing, etc. Usage based billing, static quota for the monitoring purpose. But AI approach predict bandwidth usage trends, detect abnormal usage patterns like fraud detection, etc. Then optimize the billing models, customer behavior model, revenue leakage detection. So all these things are possible with the help of AI approach. Example, detecting the unusual traffic spikes from enterprise customers and then flag possible abuse. Performance management is in traditional performance management, threshold based monitoring was there, manual capacity planning, reactive congestion handling. But in case of AI approach, predict the congestion before it happens, dynamic load balancing, SLA prediction, closed loop optimize. Example, AI can predict 80% link utilization in the next 10 minutes, which reroutes the traffic proactively. Lastly, the security management, the traditional approach says that signature-based IDs, whereas firewall rules, static access control are the traditional approach. If you use AI, behavioral intrusion detection, zero-day attack detection, insider threat detection, adaptive firewall policies, and automated threat response. So thus, example, it can detect the lateral movement in internal network where isolate the device automatically. Summary, fault management is the reactive and AI is a predictive. Then configuration is a manual in traditional things, whereas intelligent and autonomous in case of AI driven. Accounting reporting is done manually, the traditional approach. So predictive and fraud detection can be possible with the AI. So performance threshold based predictive optimization, security signature based behavioral and adaptive in nature. Lastly, let us look at the GPT. Stands for generative pre-trained transformer, which is going to be a prompt. So chat GPT copilot, then we have perplexity. What is the Google one? Gala, Gemini. So many more are there, right? So how do we use it? Any good prompt should define the context, what kind of network or device you are using. Describe the issue, what the symptoms are observed like packet loss or SNMP timeout, etc. Provide environment data like example OS type, device model, protocol versions, etc. Ask for specific help like diagnostics, commands, probable causes, or configuration fixes, etc. In case of ChatGPT, I am a network engineer troubleshooting an enterprise network. So problem is describe the symptoms clearly. Environment is topology, vendor, protocol, VLANs, routing protocol, firewalls, etc. Then ping results, trace routes, logs, errors, etc. as an observation thing. What I need is the root cause analysis for the step by step in troubleshooting the commands to run. Okay, commands to. So sometimes connecting issues, I'm troubleshooting a connectivity issue in an enterprise LAN. Users VLAN 30 cannot reach the gateway, blah, blah. Switch is Cisco layer 2, router is layer 3, core switch. I verified that the port is up or up. What step-by-step check should I perform? So that it will go into ChatGPT will list the firewall blocking traffic from subnet blah blah to blah blah is failing. So firewall is a Palo Alto, log show deny rule matched. How should I systematically troubleshoot this? So, prompt will. Connecting the issues. My router is corporate LAN is not reachable via ping from the remote subnet. XNMP monitoring is also fails. Routing seems fine. Then what diagnostic step or a command should I run on the Cisco IOS to isolate the issue? NAT or firewall issues, outbound internet or traffic sometimes work fine, but inbound request to a web server behind the firewall timeout. NAT and port forwarding seems configured. How can I trace the packets to confirm where the drop is occurring? So, whenever you use your prompts, you can also upload the screenshots or ping trace route or error message or your PCAP file also. This will help the prompt tool to develop a precise steps. Add these phrases to improve the results. Think like CCIE level engineer. Provide systematic layer troubleshooting. Start from layer 1 to layer 7. Prioritize most probable solutions. Include verification commands. Assume the production environment is to minimize disruption. Working fine with a little. And there are going to be like weak prompt like OSPF not working. Why? It cannot understand. So you have to give the scenario. Two Cisco routers running on OSPF area 0. Router A IP address is this much. Router B network address is this much. No routes learned. Neighbor stuck in two-way state, providing the root cause possibilities and providing the verifying the steps which are being followed. So thus, this will help you to prompt or use the ChatGPT in a better and a fair manner. So that's all for today. If you have any questions, we can take. Let me first stop recording this.